In this video, we'll look at how to graph log functions. We're given f of x is equal to a to the x. A is a number where a cannot be equal to 1 because 1 raised to the any power will always be equal to 1, so it's not too interesting. A needs to be greater than 0. So there's going to be cases where a is in between 0 and 1, and a is greater than 1. In the case where a is in between 0 and 1, has a graph that looks like this, where a is greater than 1, has a graph that looks like this. In both cases, they are never going to have a negative y values. Alright, so let's look at the domain. Domain of this function would always be all real numbers. So x is an element of all real numbers. What about range? Range is all possible y values. Y can never be equal to 0, so y must be always greater than 0. Is there any asymptotes? Yes, there is. In both cases, the asymptotes are on the x-axis. So, asymptotes always must be in equation y is equal to 0. What about the inverse function? Let's quickly solve for an inverse. We're given y is equal to a to the x. Change x and y, so you have x is equal to a to the y. Solve for y. So we need to take the log on both sides. So log of a of x is equal to y. Therefore, the inverse function of a to the x is equal to log base a of x. So that is the inverse function. And we can assume already what this function should look like. They are always reflective about y is equal to x. So on the first graph, where a is in between 0 and 1, has a graph that looks like this. And on the graph that's on the right side, reflective about the y is equal to x line should look like this. So in both cases, x can never be a negative number. So x must be greater than 0 for my range. All possible y values, it's all real numbers. For the asymptote, x is equal to 0. So again, if we compare what's on the left side to the right side, x is all real numbers. Now, y is all real numbers on inverse. Y is greater than 0, but on the inverse, x is greater than 0. On the asymptote, y is equal to 0. On the inverse, x is equal to 0. So x and y values, they switch on inverse functions. In this problem, consider the function f of x is equal to log base 2 x minus 1 plus 1. Find the domain and range of f. A. Since this is a log function, consider this case, the parentheses. Could 2 raised to the any power be equal to 0? No, right? It always has to be greater than 0. So x minus 1 must be always greater than 0. That means x has to be greater than 1. So that's going to be your domain. Range, as we saw it in the earlier video, is all real numbers at all time in log functions. So that's A. For B, find any asymptotes and axes of intercepts. Well, we need to look at the behavior of the function. As x goes to 1, what happens? Since it's a log function, we already know it's going to look like this. Because the base is greater than 1, right? 2 is greater than 1. So in that case, we would think since x has to be greater than 1, there has to be an asymptote when x is equal to 1. So x is equal to 1 is one of the asymptotes. Can we have a y asymptote? No, because y is all real numbers. It needs to be defined everywhere. So then what about the axis of intercepts? Well, axis of intercepts are when x is a 0, what happens to y value? When y is equal to 0, what happens to the x value? So 0 and 0. Let's look. When x is equal to 0, we have log 2 of negative 1. Log base 2 of negative 1. Is this a possible scenario? Well, we have a plus 1. But this means 2 raised to the some power gives you a negative 1. Again, it can never be a negative number, so this is not a possible scenario. So no, there is no y-intercept. How about x-intercept? X-intercept is when y's value is equal to 0. So 0 is equal to log 2 of x minus 1 plus 1. So if we move the 1 onto the other side, we have negative 1 is equal to log base 2 of x minus 1. Rewrite this into an exponential form. So we have 2 raised to the negative first power is equal to x minus 1. 2 to the negative first power is half. So half is equal to x minus 1. Solve for x. We're adding 1 on both sides, so it becomes 3 over 2. So x is equal to 3 over 2 and 0. So that is going to be this point over here. Okay, how about C? Sketch the graph of f showing all important features. We kind of have done that already. We know that the point is going to cross 3 over 2 and 0, asymptote happening at x is equal to 1, right? And basically that's it. How about if we have the inverse? Inverse, they always reflect on the y is equal to x line. So the graph of this must be, any guess? It will have an asymptote at y is equal to 1 instead of x is equal to 1. And it's going to go infinity. So this is going to be a graph of the inverse. Explain how to verify your answer. Well, one way to look at this is come up with an inverse. Then plug in the points that we know already and see if it satisfies. So we know if we plug in x for the 0 and y, if we get a y is equal to 3 over 2, so your x and y coordinates have been switched, and then if that satisfies, then you know that it has an inverse. And we have verified. So let's look at the inverse. We have log of 2 of x minus 1 plus 1 is equal to y. So switch x and y. So we have x is equal to log of 2 y minus 1 plus 1. Alright, so subtract the 1 on both sides. We have x minus 1 is equal to log of 2 of y minus 1. So we write this into an exponential form. We have 2 raised to the x minus 1 is equal to y minus 1. We're trying to solve for y, so we need to add 1 on both sides. So final answer will be the inverse is equal to 2 to the x minus 1 plus 1. So let's plug in 0 for the x. So if we plug in 0 for the x, we get 2 raised to the negative half power plus 1. Well, we know 2 to the negative first power is equal to half. Half plus 1 is equal to 3 over 2. So here we have solved that y is equal to 3 over 2. And on the original function, x is equal to 3 over 2. So here we have shown that the inverse do exist. And it works. Similar to the last problem, let's consider the function f where x gets mapped onto e to the x minus 3. Find the equation defining f -1, that means inverse. So on A, we're given y is equal to e to the x. Let's write that. E to the x minus 3. In order to find the inverse, you want to switch x and y. So e to the y minus 3. If we take the ln on both sides, since we are working with the number e, we get ln of x is equal to ln of e to the y minus 3. Using the laws of logs, we can pull out this y minus 3 in the front of ln of e. So we get ln of x is equal to y minus 3 of ln of e, which we know ln of e is equal to 1. So now just solve for y by adding 3 on both sides, ln of x plus 3. So the inverse of this function would be ln of x plus 3. Sketch the graph of f and inverse on the same set of the axes. So for b, we have y is equal to e to the x minus 3. So we would have something like this. And then the inverse, which reflects on the y is equal to x. So that will look something similar to this guy. So that would be f of x, and this would be an inverse. All right. C says, state the domain and range of f and f inverse. Well, for C, for an f of x function, we have the domain and range. Domain is x is an element of all real numbers. Then we kind of know for the inverse, don't we? Inverse is the opposite on the y, so y has to be all real numbers. Check your graph to see if that makes sense, right? X is all real numbers, y is all real numbers. For the range on the domain, y must be greater than 0. For the domain of the inverse, x has to be greater than 0. Lastly, find any asymptotes and intercepts of f and f inverse. The asymptotes on the f of x is equal to x is equal to 0. For the inverse, y is equal to 0. There is one intercept on both cases, over here and over here. If we find this coordinate of x and y, on the inverse, the x and y just switch. So when x is equal to 0, on the original function, we get e to the negative 3. So when x is equal to 0, you get e to the negative third power. You can write it as e to the negative third power or 1 over e to the third. But I'm going to keep it simple, e to the negative third. Right. So for the inverse, it would just be the opposite of that. So e to the negative third and 0.